Open up a new project, use the correct template, and save your work. We're going to build a site today before we draft the existing building. To create a site, we're going to use the Massing and Site tab at the top of your ribbon, in the middle. We're going to drop down Topo Solid, short for topography, and we're going to create a site from scratch using Create from Sketch. Draw a rectangle that is 400 by 600 feet. Select one line to use the dimension. Click the dimension and type in your desired length. (400 by 600 feet. And as you can already see, this is much larger and beyond the bounds of our elevations, so we'll correct those in a minute. Select the check mark, and let's understand what this topography is. Go to your 3D view, and notice the thickness of the grade. Select that, and for the first time, we're going to explore what exists in the Properties menu. So I'm showing Properties. When we click on Properties, if we had different types of topography, they would be listed when we click this button. Let's edit the type. So I'm clicking the button Edit Type, and I see that the default thickness is 1 foot. We can change that by editing the structure of the topography. Let's make this 25 feet thick. Select OK, OK, and you'll notice the topography now has a thickness. We've given the grade and the topography a thickness so that we can dig into the earth and excavate. If we want to manipulate the site, we can include mountains and hills, but without a thick site, you cannot go below the 1 foot. Let's go back to level 1. Click the small triangle of the north elevation symbol to see where the view line is. Then grab the square and move that symbol to the north side of your site. Click the triangle to make sure the view came with it, and do the same thing for the east elevation. We're going to add points in order to create mountains and valleys on this site. Let's go to the 3D view to create mountains and valleys. When you click the site once, what we'd like to do is add points for high and low points. So once we click the site, we get the menu on the right side of the ribbon where we are going to add a point. Click the top view of the cube on your right-hand side and place 3 points on the top edge of your site and 3 along the bottom. Rotate. Again, I'm holding Shift and pressing down the cursor of my mouse, and hit Escape once. You can simply select each point you've created and give it an elevation manually by looking in the upper right-hand side of the ribbon, or you can use the tabs to raise that elevation and see quickly how we can create mountains. Let's do the same thing with the other 3 points, understanding that you can only go down to the 25-foot depth because of the thickness of our site. Click off the site or escape to see the entire landscape. If we want to create a building on this building pad, site pad, let's use the floor tool. Again, let's orient this to a plan view by selecting the top of our cube. And we're going to look for floor. We've never done this in the architecture tab. And there's a button near the middle thing that says floor. Let's click on that. You'll notice that the properties menu shows a concrete slab, and that is fine. Draw any size rectangular floor near the bottom of the slope of your site, and let's click the check mark. I received some warnings in Revit. It's always nice not to immediately go to the right X, but read what they say. In this case, my topo solid and floor are overlapping, but we're going to excavate the floor so that that does not occur. So you can hit the X, we understand the issue, and we'll rotate around. In order to excavate so that the floor doesn't intersect but cuts the earth, touch the earth. In your ribbon, you may see excavate as an option. It is this button, or we can use the keyboard shortcut EX. When I type in EX, Revit then asks me near the bottom of the screen, if you're in a command and you don't understand what you need to do next, take a look at the message that Revit gives you at the bottom of the screen. So it's asking you to select the element to excavate the topo solid, and we want to select the slab. Hit escape a couple times. We've been locating everything that we draft on the level 1 plan view at this point. We can change the elevation of floors in the elevation view. We've been working with the south elevation, or you can type in a numeric value using the properties bar. At the top of the properties bar, it lets us know what level that floor is located on. Here, it was actually on bottom of footing. You can click to the right-hand side of that row and choose level 1, and you'll notice that the floor lifts. You can also give it a height from a level. If I said 25 feet here, it would move the floor up that way as well. I'll hit Control Z, so that we see the excavation. We're going to use another program in order to understand more about the building that we're going to draft. We're going to go to Google Earth, and I'd like you to type in this address in Cesson, France. Once you're at the site in Google Earth, we're going to use this ruler, the measuring distance and area tool, in order to understand elevation heights and the size of the structure. So click on the measuring tool, and you may need to change your settings to inches and feet. But I'd like you to understand what the scale of that 400 by 600 site is, specifically looking at the surrounding of this building. So that's about 400 feet, and you can make a square. It adds the dimensions, so go to about 1,000. And here we understand what the site looks like. You can also scroll around to also get an idea of the topography here and the elevation height. Click on the 2D button in the lower right-hand corner of your screen and hover around the building, specifically the site around the building, and keep your eye, I'll move my cursor, to this lower right-hand elevation dimension. So as my cursor moves, I see 806 and I see 763. So not only visually, but numerically, I can begin to understand what the elevation height is doing in this area. I'd like you to pay attention to those elevation markers from left to right and in the opposite direction so that you can create a similar site in Revit. So I'll give you some time to do that. The next thing that you will do is to develop a building pad on the upper left-hand side. Let's create a building pad that represents the base of this structure at 23 feet wide and 70 feet long. Now you may have created and placed the 23-foot by 70-foot concrete back into the hillside, but it still looks really low. So that the floor level is not this far down in my topography, I'm going to lower the topography to maintain the level 0 of my building pad. Let's go to the south elevation. Here I see elevation markers and the entire site. I am going to touch the site and drop it down, move it down 70 feet. Let's go back to the 3D and see that my building pad is now near the top. If in the plan view, when you select the triangle of the elevation symbol and you do not see the little tab grips that would allow you to show the entire site, you simply need to go into the properties bar after selecting the triangle of the symbol and click on under the extents row, the crop view, the crop region, annotation, and at far clipping, select that box. Mine originally was on no clip, but clipping without line, clip without line, will allow you to adjust that. You may need to switch that on all of them. That is what the original view looked like for me. We're going to learn more about the architect Odile Decq and the St. Ange residency, the building that we're going to model in Revit. Artist residency called St. Ange. This project is located in France. Odile Decq is an architect that studied in France. She started her own firm in 1979, and then in 2014 decided that she was going to open up a school. For the St. Ange residency, she was tasked with creating a building on the site of an owner who'd like to host artists in residency. She talks a little bit about her interactive, intuitive process, the way that she uses model making to create her forms. As we can see in the example here, it is not an easy form to create. And she was inspired by the Grenoble mountainous region. So you can zoom around in Google Earth to see the mountains that she's discussing. And she wanted to create a lookout tower toward those mountains for this project. So the artist residency. This is an award for those who provide portfolios or lectures and win a time period in a different place where they can study or perfect and complete work on the site of a residency. In many different places, these can range from a few weeks to maybe even 6 months or a year. But the majority of the space we'll be looking at is given over to this artist space. That's the 2-story volume you see on the bottom. That lit window that we see in the left image gives us a view into the clear story, bright windows. That's the bottom base of this entire building. And we see a few different views of the tower as we move around in different images. These are going to help us create the building in SketchUp. Also find a section or an elevation view so that we can import that image after understanding the levels. We're going to rotate that, which will help us create the overall volume. So let's look at the floors. You're going to import the images, arranging the floors from the bottom of the page to the top of the page as a building grows toward the sky itself. So start on the base. We see the location of the garage door on the left bottom image, and a circular stair that's going to organize and orient us from the bottom of this residency building all the way to the Lookout Bellevue Tower. Locate the second floor above this first floor plan. It has a mezzanine with an entry door. Let's continue to import the third, the fourth, and the fifth level. Third level has the kitchen. Again, we can see the organization around the center stair, casework, and a kitchen table. Some interior images also help. And then import level 4, which is the bedroom. And level 5, which is the tower above that. On Blackboard, I've collected all of the floor plans that we need to drag into Revit and then rescale. Because we're using existing plans, we can use these images at the correct scale to help us develop the floor plans. So let's find and pull those drawings into Revit. You have quite a few drawings in that zip folder. We have elevations, but let's focus first on the floor plans to make sure that you arrange them in the right order. So we're going to place level 1, 2, 3, 4, and 5 from level 1 at the ground and work up to level 5. Go to level 1 in Revit, select level 1, and drag it in to the program. If you receive an error message, it's because these drawings need to be out of the zipped folder and on your desktop before you drag them in. I've placed each floor plan into the drawing, going from the first level up to the 5th, the Belvedere. You can see that all of the images imported at different scales, and none of them are at an accurate scale. I'm going to use the rescaling tool, RE, to correct each of these images. The consistent thing that I see on each image is the length of the line along the left side of the plan. That should be 23 feet. So for each image, I am going to draw LI for a line along that left edge. LI. For me, the line length is at 42, meaning it's too long. I need to draw a second line, LI, at 23 feet. I'm typing that in. And to rescale, I'm going to select the image, type in RE, click the edges of the image first, bottom edge, top edge, and drag my cursor back until it snaps to the end point of 23. I'll delete my second line. And I have my first image scaled accurately. We're going to do that for each of the additional images. I can use this line again, CO, grab an endpoint, and locate it on the next image. And continue to do the same thing. So I'll let you do that for a few moments. Now all of the drawings have been scaled. I'll zoom in to the first level. I'm on level 1, so I'm going to draft the first level on this level. We'll be using multiple levels today. The first thing that I'm going to do is to understand the thickness of the wall. I'm going to use the Massing and Site in-place mass tracing tool again, but I want to understand offsets before I begin. I'll zoom in, and the construction looks like there is a veneer. We'll look at the wood veneer on the elevations, a concrete hatch, an airspace, insulation, and an interior veneer. If I want to understand the thickness, I can draw LI line on my scaled image to determine it is 1'8". Okay, let's begin. Now that we have everything scaled, what we're going to do is create overall exterior forms using the Massing and Site tab. If you remember back to our first lecture, when we create large masses, we can then create a wall by face, thereby thinking of the entire project as a large exterior form, and we will continue to work down to the detail level later. Let's look at the first floor to begin. So I'm on level 1, and I will be drafting level 1. Let's go into Massing and Site, In Place Mass, and let's call this level 1 mass. Again, overall form, no openings or windows yet. In the Create tab, I'll select the Line tool and trace the perimeter of this object. We want to select all of the lines we've just created, which lets us look in the right side of the ribbon for Create Form dropdown, and we'll create a solid form. As we build the next few levels, let's build them at 10-foot intervals. So from level 1 to the mezzanine, level 2, there's 10 feet. However, thinking back to our lecture, that is a 2-story interior volume. So we will extend the form that we've just created up to the 3rd level. But let's go into the elevation view of the south elevation in order to establish our levels. I'll click on the small triangle and note that my elevation view does not include the elements that I'm drafting. So I will correct the location of that line. Now when I go into my south view, I see the element. However, when we went into our south view earlier, none of these levels, so I've clicked into the south view, respect the building elevation at all. We're going to draw levels here at 10-foot intervals. we can leave the footings where they are. Let's change roof to be level 2, mezzanine, simply by double-clicking the name. We will say yes, all corresponding views. And let's place 10 feet. All I did was touch the dimension number twice and altered it. You can create levels many ways. I simply typed in LL for level. I'm going to hover my cursor. It's placing the name on the wrong side of the line, which is okay. We can do the next one differently. If that happens, all you do is select the line, and we'll see small check boxes that represent where you'd like to name the level, and I'll simply click that one on. Type in LL again if I want to go from left to right. Hover to get 10 feet. Drag. It's saying it's outside of my view. This is like a picture frame. It's called a crop region. If you select the frame, there are bubbles in the center that you can drag up, and it allows you to see the entire drawing. Okay, we have 1, 2, level 3 should be level 4, level 2 should be level 3, and we have one more, the 5th Belvedere level. Another way of doing levels, creating levels instead of LL to make them, is simply by copying. You can touch the level line, CO, touch the line, type in 10 feet, enter. Now some of our levels have blue symbols, others have black. This means that in our project browser over here, I'm going to minimize ceiling, that none of our levels are showing up as floor plans yet. I see I have level 1, a mezzanine, and other levels, but I don't have 3, 4, and 5. In order to get levels into the project browser, we're going to go to View in the ribbon, Plan View drop-down, Floor Plan. Select everything by holding down Shift, type OK, and you'll notice now in our project browser that 3, 4, and 5 exist. The level lines are far away. If I click on one and zoom in between the symbol and the name, there is a small bubble. I'm going to grab that, holding down the left cursor, zoom out, and drag that all the way through the building. So I see I've created a form that's pretty tall. I'd like all of these elements, though, to end at level 3, 20 feet tall. We're going to copy the level 3 image from level floor plan 1 and create that level in the correct floor plan. Back to level 1, copy level 3. Level 3 has the kitchen. We see a small table, doors that open out onto the roof deck, a sink, a range. Control C to copy this image. And let's double click in level 3 using our project browser. We can look into our properties browser. Search for a row called underlay. And what this means is that what is the base range that we can see to? It's currently set at none. So let's change that to allow us to look down at level 1, and we see the form that we've created up to the mezzanine. Now, let's copy in from level 1 the level 3 plan so that we can trace its volume. I'll Control C, Control V, and then zoom in so that we can align that image. And what you'll notice here is that there is a perimeter alignment. You may need to rescale your image if it doesn't look exact or very similar to the way I've aligned mine. But it also has this thickness, so the cut of the wall is inside that perimeter. Think of a pyramid. At the base, the walls are their thickest, but a floor plan cut is 3 feet above ground level. Therefore, when we cut floor plans with angular walls, those walls are going to look more narrow or interior to the original base plan. And that's what we see here. The next form we create is one that is going to respect that perimeter wall of this plan. We're using the massing in sight type of modeling so that we can drag and align those walls in elevation and 3D form using the X, Y, and Z component tools in that command. So let's trace this and create a second mass. So we'll go to Massing in Sight, In Place Mass. Let's call this level 3. And trace. Again, once we create wall from face, we will include windows and doors. Okay, we'll make sure that form closes. I select all of the lines, look to the right side of the ribbon, and create a form. Let's take a look at what this appears to be like in 3D. If I finish the form. Okay. My original form is too tall. Okay, let's go fix the levels when we're looking at this in the south view. So I've clicked to the south view. My base form is too tall. We'll bring that back down to level 3. And then because the floor plan cut is 3 feet above level 3, let's pull this volume up 3 feet. I use DI to allow me to dimension that accurately. And we'll align all the forms once we've created all of the levels. So 2 to go. Let's go back to level 1 and copy in level 4. Control C. Go to the project browser, double click level 4. I still don't see anything. So how do we do that? Properties, underlay. Change the base level. Let's look at the mezzanine. Which isn't telling me too much here. What does level 1 look like? About the same. Okay, we'll stick with mezzanine. I will Control V to paste. And let's see how this one aligns. Let's trace this perimeter. Massing in sight, in place mass. Let's call this level 4. And notice some of the nuances of this cut. If you find that you cannot see the wall, we can always choose, okay, to move the image out and then bring our volume back. It's interrupted by the form below. I'll pull this drawing down 100 feet and do the same thing again. Massing in sight, in place mass, level 4. And trace. Now I can see the entire image. Okay, select the perimeter, create form, solid form, and then let's bring both, finish the mass. And let's bring both back up by selecting each one together, MV 100 feet. Let's look at this in 3D. Okay, I need to adjust the plan cut to be up 3 feet from the south elevation. And finally, let's do the Belvedere level 5. Back to level 1 to copy that plan. Go to the project browser, level 5. I don't see anything. Properties, base level, do the level below. I see the image. Control V copies our image. And I'm going to use this corner to start. Can begin to understand the alignment below. Okay. Let's use massing in sight. And here, although it does not appear that we have a planned north wall, we are going to close off that volume and create the Belvedere when we create walls from the mass. Level 5. Select everything, drop down create form, finish the mass, look at it in 3D. Good. And you'll see, even though we're aligning our plans, because of the angle, I'm going to hide the levels here so it makes things a little easier to see. Because of the angular level, these don't appear to align yet. Let's go to the south elevation. Bring the base up 3 feet. And pause. I'll take a look back at the elevations. If we look at the floor plan and the direction we've put them in our drawing, in the lower right-hand corner, I'll use my mouse to look at this look at the bottom left image. There is a straight line from top to bottom. And my Revit drawing really doesn't respect that. You're going to spend time now dragging each wall line in order to visually, again, this is an exercise of many different opportunities. Exact dimensions of the residency is not something I am grading against. We're learning lots of new things in Revit. So, to the best of your ability, we're going to use this corner on the lower left-hand image to be the datum point now. It's straight. And then turn your model in 4 directions in order to try and achieve the angles we see in the elevation. So we'll spend quite a bit of time doing this before we create walls and floors and roofs out of the form. If you ever open up Revit after a crash and don't see your masses, Revit likes to hide some things, so before you worry, look at the bottom of your ribbon and click on the light bulb to reveal hidden elements. I'm going to drag my cursor, click right, and unhide the category of model and click back out. So we're talking about the alignment. And originally, my floors were not aligned to the back datum point, the straight line that we see in our PowerPoint. I corrected that by selecting the Belvedere top view and using my cursor. Let's say these are all over the place. And selecting each level, MV to move, touching the corner point and snapping to the back to align those levels. Okay. Now we can compare what each of those look like against the elevations. Okay. So let's start with the first floor. I know that between level 3 and the mezzanine below, or that top of that 2-story space, the building moves from this point to the top of wall. I also noticed that the roof of that 2-story space from the ground level reaches up and to the right. So let's work on those 2 things to begin, and then I'm going to let everyone draft on your own because we all see this a little differently. When I touch the 3rd floor to edit in place, because I've created this with massing in sight, I can simply take this line, type in MV, and align it to the lower level. We can adjust these in a moment. Click off and finish mass. A few of my dimensions will be eliminated. I know that this point goes straight down. Edit in place, use MV to drag that line down and make sure that the back corner is still aligned. It's not. I'll use that point to bring that point to the edge. I'd like that middle point simply to go down to level 3. Okay, my building is starting to take a cohesive shape, at least between this first, second, and third level. I'm going to finish the mass and work on the roof that lifts. I gauge that the roof lifts about 3 feet. I'm going to edit this in place and draw a line from the 2 points of level 3, making sure they do intersect, with the back angle and the front connection. You can see mine is not perfect. So that when I lift this, the hope is that it holds that line, which it didn't. If you want to slice lines at any point, you can use the SL Slice Line tool. And if slicing doesn't work for you, it didn't work for me while I'm in this command, we can always edit the profile. So we'll go one layer deeper, edit profile after selecting that line, and try slicing within that at the intersection of the mezzanine. We'll hit the check mark, tab a couple times to grab the top edge and lift, and it works. Okay, we were at 20. I'm going to raise this to be around 24 feet. Okay, so take your own time and let's meet again when we have one solid form. We're going to create walls and roofs by using the drop-down menu under the Architecture tab and selecting Wall by Face to begin. We're going to do the same thing under the Roof command. I'm going to begin by going to the Architecture tab, clicking the drop-down marker on Wall to find Wall by Face. In the Properties bar, we know the wall thickness is 1 foot 8, but that doesn't exist. Let's begin with the generic 12-inch, and we can change the dimension later. Simply select the face of the wall and move around the entire form to create walls along the first level. Hit Escape once, and we'll create a roof. Under the Roof tab, we can find the same drop-down options and choose Roof by Face. And we can choose the 2 planes of the roof. And I let what was automatically the roof selection be the type of construction. From this point, you can hide. I'll select my mass model in EH to element hide, and then begin to go back to level 1 and look at where to locate the garage door. That mass still exists in level 1, so I can touch it and select EH to element hide. I realigned the photograph. And to locate the garage door, we're going to use the WO, wall opening command. WO, select the wall where we'd like the garage door opening, and then drag it. And let's look at it in 3D. We can adjust the height by comparing it to the original image. I noticed there is a triangular ribbon window that increases as the roof lifts left to right. We're going to create a curtain wall that goes from the flat level of this wall and then lifts to mimic the line of the roof. Let's go to our level 1 plan. We will draw the curtain wall to intersect this generic wall by selecting the type of wall. Let's go to WA for wall, click on the Properties bar, and scroll down until you see Curtain Wall. Click Curtain Wall, And we are going to draw a wall that intersects. We get that error. And then one more. Then we will go to the elevation view to correct it. Our curtain wall is hiding within. I selected the first wall, typed in EH. You can hide anything with element hide. I'm going to touch the curtain wall and ask it to attach the top to the roof. So once I select it, I attach the top and then choose the roof. If the roof does not overhang the wall, it will not attach. So we can simply select the roof and drag it farther out in order for the curtain wall to locate itself to the roof plane. I'll touch the curtain wall and then use the bottom tab to bring this up as I compare it to the original image. It looks like that point begins near level 3. In order to shorten the wall, I simply selected the curtain wall, touched the top button of my cube, and used the endpoint to drag it into the 2-story space. If when you connect this curtain wall to the roof, there's a part of the wall that's lifting up, it could be that we need to connect it to the second plane of roof, but why don't we correct the curtain wall on this right side of the figure before we do that? In order to bring back the original wall of the front face, you're going to go to Reveal Hidden Elements, the light bulb at the bottom of your screen, and right-click on the wall to unhide in view the element. Click the light bulb again, and we'll see that the curtain wall is now cutting out. No, it's not. In order to cut the geometry out from the main wooden wall, let's explore keyboard shortcut to cut the geometry. Keyboard shortcut. Cut geometry. If we don't have a keyboard shortcut command, which it looks like we don't, we're going to find that button, Cut Geometry, in the Modify Geometry tab. So you can create Cut Geometry keyboard shortcut, or simply look for the Modify and Geometry. In order to cut the host wall, the generic wall, we're going to go to the Modify tab, choose the Cut Geometry button, choose the host wall first, and then the wall we'd like to cut the host wall with. Let's do the same thing for the right side of the geometry. Our curtain wall is embedded within. We'll begin by attaching the top to the angular roof. Let's select, because we have a curtain wall within the host wall, touch the edge of the host wall and select Tab. And I'm going to bring that wall down a little bit and lift the curtain wall within. You'll see that it is attached to the roof. If we want to correct this curtain wall overhanging the original slanted roof, we can select that front curtain wall again, attach to top, and select that second plane. Now all of the curtain wall glass is within it. This one is non-angular, so we could cut geometry, or we could simply match the height. On your own, I'd like you to insert all wall openings, doors, and windows by referring back to the plans and the PowerPoint at each level. You can work on your own. You're going to use 2 new keyboard shortcuts for door and window. To choose to put a door in a wall, you simply use the keyboard shortcut DR and then hover. The door comes up automatically. Hover the door in the wall you'd like to locate it. The window tool is WN. And you can locate the window in the same way, locating and hovering over a wall to locate the window. So go ahead and do that on your own. We're going to locate a spiral staircase and go from just level 1 to the mezzanine to begin. Because every level is 10 feet in height, we can create one stair and then copy it up to level 5. In our tabs, let's look under Architecture and find in the middle of the ribbon the stair. Click on the stair and take a look at what's under the Modify ribbon tab. We have a few different types of spiral stairs, and we're going to use this full step spiral. Let's click on that button and pay attention to the properties bar. Revit automatically locates the number of risers that we need to go from level 1 to the mezzanine. Let's click once in the center of the stair we see on the plan. And you'll notice as you radiate out from that point that your stair is in a ghost form. Let's try to match it as close to the 3-foot distance as possible. Click once, and let's explore what that looks like in 3D. I've drawn it outside of the building so that you'd be able to see it. You're going to select that stair after you hit the check mark. That completes the stair with railings. Let's grab the stair, hit Control-C to copy it, and then in the project browser, go down to level 2 mezzanine. You're going to scroll into your building. I've drawn mine off to the side. And we can paste in a specific way. It's already copied on our clipboard. Go to the Modify tab in the ribbon. Drop down Paste. Want to align it to current view. We're going to choose this option. And that will locate the stair exactly over top of what we've drawn on level 1. Do that for level 3 and 4, and that last riser should appear then on level 5, getting us from 4 to 5. So go ahead and do that on your own. We're going to import furniture next. I've come to level 3 so that the image of furniture below my draft is showing. I'm going to try to find a table and chairs to begin. You have to sign in to Revit in order to access the cloud system of furniture. We're going to go to the Insert tab and load Autodesk families. Here, as you can see, as we scroll the browse screen on the left, that we have lots of different options, many details, casework options, lighting, structure, all sort of beams. But we're going to make an easy search for a table. Try to find a table with chairs, even though it might be too large. Click this once, table dining round with chairs, and select load. And then you wonder, where is it? We find any family that we load in this way by going back to a component model. The first tool we learned to draft, CM. Component modeling, and I'll switch to my properties, pulls up all the families loaded in our project. And it looks like we've got a few different diameter tables that imported. I'll choose the 36 that's coming in, click once, and now I have furniture. Let's see if I can take a look at this in 3D. I'll hide a few of my walls. Oh, here it is, floating. So we have a three-dimensional element of furniture. Go through levels 3, 4, and 5 and place in the furniture that you see. To search for casework, you can do cabinetry under the casework search. To prepare your items for the next part of this project, the poster part, I'd like you to take images and exports of plans, sections, and elevation views. You are already familiar with the plans and the elevation views, but we've never drawn a section. So let's draw one section together so that you have that to export as a part of your files. I'll begin the section cut in plan. So in the View tab, in the middle of our ribbon, we're going to select the section button. It's as simple as this. I'm going to select the left side, and I'm trying to go parallel with the front wall in this cut, and select and touch my cursor one more time. In the same way that our elevations work, we can double click the triangular part of this section to bring us to the section. And now I see the cut through my building. If I touch the frame, I can drag the crop regions from it. Going back to level 3, if I double click on that section 1 option, it will bring me to the same location as clicking on the symbol of the section marker in the plan view. So go ahead and export those options, and we'll be ready to experiment and research rendering programs.